Okay, so our topic will be Bernoulli principle with the reintroduction to pumps. Okay? Okay, so we are done with the discussion ng Bernoulli equation last time. And I want to just recall yung mga uh, notable topics and idea na napapaloob dito sa Bernoulli equation. What did I say? Pagdating ng Bernoulli equation, okay, that the energy that is entering at the suction will be equal to the energy that will be going out the discharge. So, E in is equal to E out. Ayan. E in will be equal to E out. Ayan. For continuity equation, we have this equation. Ayan. Saan yan ang galing for continuity equation? According to continuity equation, the fluid flow, okay, yung mass will always be, yung mass flow daw at the inlet will be the mass at the outlet. Conservation of mass, okay, can never be destroyed, di ba? Nor created. And saan ba equal yung mass flow rate mong yan? Your mass flow rate, you can get it by using the density of the fluid that flows within the boundaries of the pipes, the area of the cross-section for the fluid to flow, and then the velocity of that fluid flowing. Dito na yan. And recall that the density of water, which is the relative substance that is equal to 1 kilogram per liter equal to 1,000 kilogram per cubic meter. In imperial units, water is at 62.4 pound per cubic foot. Okay? Pwede rin na ang density niya. Density ito kasi specific weight to eh. Okay? That is the density. Paano naman kapag density ng air? Okay, density ng air naman. That is equal to 1.2 kilogram per cubic meter. Or 0.075 pound per cubic foot. Ayan ha, binigay ko na sa inyo. Going back with the figure, as you can see, we have the Bernoulli equation here coming from the energy equation. So, we balance out the energy that is going in and then the energy that is going out. Okay? Doon natin i-determine yung head. Okay? Yung head na yan, pwede mong kunin yung pressure head, velocity head, and then the potential head which is affected by the placement or elevation ng inyong piping. Okay? Or ng inyong fluid flow. Now, as you can see, meron tayong diagram dito. If this is the suction, if this is the discharge, we have a suction pressure, a discharge pressure, a size on the suction, diameter of the suction, and then the diameter of the discharge. Now, this is your pump center line. As we can see, how can we determine yung different idea na mapapaloob dito? If this is the suction, this is the height of the discharge. How can we say that your suction will be negative and positive pagdating ng elevation? Now, remember this. If ZS is below pump center line, we can say ZS is negative in value. If this is above pump center line, the value will become positive. Okay? Now, how about the pressures? How about the pressures? Okay? If yung pressure mo sa suction is at vacuum, we can say the pressure is negative. If regular lang naman, if not, otherwise. Okay? Positive. Yan. For head losses, they are always additive. Add mo parate. Now, let us determine here yung head total na sinasabi dyan. Now, the total head that is equal to the change in velocity head and then the change in elevation head, the change in pressure head, and then the change in head losses. Yan yung entirety. Okay? Now, again, this is elevation. No. This is velocity head. This is elevation. This is pressure head. This is head loss. Now, saan natin makukuha dito yung velocity head natin? Take note that at your suction, you have a velocity of the flow. And at discharge, you have a velocity of flow. Okay? Recall, okay? The flow within the system, the flow at the suction, and then the flow at the discharge will always be constant. And that flow is equal to the area of the flow. You just have to multiply it with the velocity. Where the area of the flow, circular naman parati ang ating pipe, is pi over 4 d squared and then multiply it with the velocity. In this case, we can get the velocity. How? We can get the velocity by, kunin mo dito sa equation na to. The velocity will be what? Oh, cross multiply natin, okay? So 4q divided by pi d squared. Always ito. Okay, always yan. Always ganyan po siya para makuha mo yung velocity. Now, let us have this in elaborate form. Okay? Expand natin siya. If this is a change in velocity, okay? So, v at discharge is squared minus v at suction is squared divided by twice of the gravity. Plus, yung head niya dito. So, Zs or Zd minus Zs. Nakadepende if this is positive or negative from the placement. Okay? Plus, yung head of pressure, P2 or PS or PD minus PS divided by the specific weight of the fluid, which is commonly water, plus the head losses. The head losses, bakit po lagi siyang additive? Because the head losses should be compensated with the amount of head na ipoproduce mo doon sa iyong pipe or sa iyong pump. Yung head losses mo at suction will be added to the head loss of the entire system kasama yung head loss at the discharge. So, head loss at the discharge plus the head loss at suction. This will become the total dynamic head. How about yung NPSH? Net positive suction head. Net Para hindi malito. This is the totality of all the suction heads. Yung sa suction side laang. Now, net, net, positive, discharge head. Meron bang ganun? Ito lang parati kinukuha dyan. Ay, NPSH, siya lang yung tatandaan nyo parati. Net positive suction head. Net positive suction on the suction side. Okay, meron pa ba dyan? Pwede pa natin tong i-extract. Pwede pa nating expand itong equation na to. Going back. Head total. Di ba ang velocity natin, recall mo dito, that velocity, recall, velocity is equal to 4Q over pi d squared. Lagay natin dito. Para isang pindutan na lang po sa calculator. So, that is VD. So, 4Q over pi d squared ng discharge. Naka yung value niya, squared, minus 4Q over pi d squared suction. Naka-square pa rin siya, divided by 2G. Plus, yung sa discharge, plus minus ZS. Plus, P, D, PS, plus minus, divided by sa fluid, plus head loss at the discharge, plus head loss at the suction. So, pwede nating isang pindutan lang para makuha natin yung kanyang total value. Okay? Ganun lang po yun. Now, what is the measure of your head total? Yung head total nyo or the total head is measured in meter column of fluid, which is commonly H2O. Water. Ayan. Okay? Or feet of H2O. Yun lang yun. Now, yung Q naman, balik tayo. Your Q. Okay, yung Q. Q is commonly pag sinabing in measure of Qmex, Qmin, ano ito? Cubic meter per second. Ito naman, cubic meter per minute. How about LPM? LPS. Liter per minute, liter per second. Ganun lang yon. How about FPS? CFS pala. CFS. CFM. Cubic foot per second, cubic foot per minute. Okay? Cubic foot. Ito, GPM. Gallons per minute. Okay, anong conversion? 1 gallon. Ilan? 3.785 liters. 1 cubic foot. Ilan? That is 7.481. Ano? Gallon. Okay? Yun lang po yung tatandaan natin pagdating ng head. So, I will be discussing yung pumps next meeting. And in order for you to grasp the entire knowledge for Bernoulli's theorem, Bernoulli equation, all we have to do is to solve the following problems. I have here 7 problems. So, the time would be suffice na para matapos natin sila. So, let us go with problem number 1. This is problem number 1. Water from a reservoir. Okay? A, 10 meters elevation is drawn by a motor-driven pump to an upper reservoir B. So, if this is A, this is B. And reservoir A is elevated at 10 meters. And reservoir B is elevated at 72 meters. Suction and discharge head loss are 0.15 meters respectively. So, suction and discharge, ibig sabihin, this is the total head loss. For discharge rate of 15 liter per second, find the total head for the piping. So, we are ought to find the total head for the piping. Yan. Okay. Sulat natin, ang hinahanap dito is total dynamic head. Okay? Let me just release my calculator. Yan. So, ang hinahanap niya dito, yung, meron ka pala dito, Q is equal to 15 liter per second. Now, ang hinahanap natin is the total dynamic head. A total dynamic head is equal to yung elevation head plus the velocity head plus the head or pressure head plus the head losses. Now, anong binigay dyan? Nagbigay ba dyan ng pressure difference? Wala siyang binigay, so we have to cancel yung pressure head. Nagbigay ba dyan ng area of the flow? Hindi. Yun pa lang, kapag wala ka ng area of the flow, pwede na natin itong i-eliminate. Okay? Zero yan. Zero to. Ano lang po yung binigay dyan? So, meron kang total head loss, meron kang binigay na elevation loss. Elevation head. So, for the elevation head, tignan nyo. This is the pump center line. Now, it is above the pump center line. Ibig sabihin dito, Zs is positive. Now, Zd minus positive Zs plus 0 plus 0 plus head loss. The total head loss there is 0.15 meters. Okay? Mamaya natin lagay. Head loss. Okay. Zd is 72 minus positive 10 plus 0 plus 0 plus 0.15. What will be the answer for the total dynamic head? So that will be 72 minus 10 plus 0.15. The answer is 62.15. 62.15 meters of H2O. Next problem, number 2. Water from a reservoir is pumped over a hill through a pipe 900 millimeter in diameter and the pressure of 1 kilogram per cm squared. Okay? 1 kilogram per cm squared. So, ang binigay dito na pipe is okay. Nagbigay siya dyan ng size of the pipe 900 mm and then pressure suction is 1 kilogram per cm squared. At the pipe discharge, where the pipe is, so discharge to. And the pressure of 1 kilogram per is maintained at the discharge, pipe discharge. So ito, discharge to. Muna natin lagyan ng label. So P. Where the pipe is 85 meters from the center line. So this is 85 meters. This is the discharge. And then the suction head, positive suction head of 5 meters. This is the suction. Okay? Ano pang binigay? Friction losses is equivalent. Friction losses is equivalent to 3 meters. So, meron kang head losses dyan. Of head loss. what is the head that should be pumped? What is the head that should the pump cover for the system? So, yun yung head na hahabulin ng pump mo. So, tignan natin dito. Notable keys for conversion. So, 101.325 kPa is equal to 1.033 kilogram per cm squared. Okay? Yan yung atmosphere. Na, meron ka ditong Q na 1.5 cubic meter in every second. Meron kang suction pressure dito, wala. Pero meron kang discharge pressure dyan. The pipe is, the discharge is 900 mm. Yung kanyang diameter. Ayan. So, anong hinahanap natin dito? Yung total head niya. So, the total head now, sulat mo parate, is equal to head ng velocity plus elevation plus yung pressure plus head loss. Meron ka bang binigay na pressure dito? Meron. Okay, ano lang ang wala sa'yo? Yung discharge lang. Okay? Yung suction dito, wala kang velocity at suction. 0. Okay, ito atmospheric. Kaya 0 pa rin. So, isimplify natin to. So, head total, yung velocity head natin, saan mo makuha? Q is equal to AV. Wala tayo nito sa 2. Okay? Subtract muna natin. So, VD squared minus VS squared over 2G. Plus, ito, ZD minus, nagbigay siya dito, 5 meters. Hindi ako nagkakamali. 5. So, below the pump center line, that is, ZS is negative. Tama ba? Pag below pump center line, that is negative. Tama. Recall natin. If below pump center line, asaan yung aking sinulat dyan? Pump center line, positive. If below pump center line, negative. Ay, negative yung ZS mo. So, negative ZS plus sa pump tuloy sa pressure, that is PD minus PS divided by yan. And then, yung head losses total. Now, meron bang binigay dyan na suction velocity? Wala. Wala ka rin naman binigay ditong size. So, assume natin 0. Tapos, yung iyong PS ba nagbigay 0 rin. So, pwede nating simplify yan. Simplify na natin. So, VD. Diba? V is equal to 4Q over pi D squared. Ayun, lagay natin dito. So, 4Q over pi D discharge squared. Tapos, naka-square pa rin yan buo. Divided by 2G plus ZD plus ZS plus, kasi negative, magiging positive. Ito, PD over gamma plus head total ng losses. Now, kunin natin yung value. So, 4 times Q, 1.5 meter cube per second. Okay, divided by pi times diameter of the pipe. Lagi mo na po itong i-divide ng 1,000 para maging meters. So, 900 divided by 1,000. So, that is 0.9 meters squared. Tapos, square mong buo. Divided by 2G. 2 times 9.81 meter per second squared plus ZD. Yung ZD mo dyan is 85. plus 5 na binigay plus PD. Ano yung binigay sa'yo dyan? 1 kilogram per cm squared. So, 1 kilogram per cm squared. You multiply it with yung conversion factor niya, 101.325. 35 tuloy. 325 kilonewton per meter squared or kPa divide by 1.033 kilogram per cm squared. Okay? Divided by gamma 9.81 kilonewton per meter cube. Meron pang head total. Binigay yung head total dyan. Head loss total equivalent to 3 meters. So we can calculate all the value for the head total. So head total now will be, yan yung hahabulin ng pump mo. O, dito muna sa taas. Huwag kalimutan ha. So, square mo na kagad yan. So 4 times 1.5 divide by pi multiplied to 0.9. Kailan gumamit yan? 0.9. Square natin yung value. Divide by 2 times 9.81. Isang pindutan natin yan, kaya natin makuha lahat. Plus 85 plus 5, 90 mo na kagad. Plus 3 plus parenthesis. So 101.325 divide by 1.033. Kaya saan po napunta yung 1? Oy, multiply mo naman yan eh. Ganun pa rin ang lalabas dyan. Divide by 9.81. The answer will be 103. 103.28 meters of water. Yan yung head na ahabulin ng pump. For problem number 2. Next problem. Okay. Water from a reservoir is pumped over a hill through a 450 millimeter inches in diameter and the pressure of 1 kilogram per cm squared is maintained at the summit. Water discharge is 30 meters above the reservoir. So, nasa taas na naman ng reservoir. The quantity pumped is 0.5 cubic meter per second. Now, the frictional in the discharge and the suction pipe and pump is equivalent to 1.5 meter head loss. What is the head that should the pump cover for the system? Ganun ulit yung question. Okay? Pabalik-balik lang. Kukompute mo na lang yan. Okay? Oh. I-extract na natin ulit. Expand na natin. So, head total. O, yung mahaba na equation. So, unahin natin, ZD minus ZS. Walang binigay sa suction dito. Zero natin yan. Plus PD minus PS divide by specific weight ng motor. Wala naman binigay sa suction. Wala ka naman nakita dyan. Ito lang binigay, oh. Yan lang. Plus VD squared minus VS squared over 2G. May binigay ba suction? Wala na naman. Zero. Plus head loss total. Check. Meron tayo dyan. Head total is equal to ZD. Anong binigay dyan? 30 meters above. So positive. 30 meters plus yung discharge. That is 1 kilogram per cm squared. O di 1 kilogram per cm squared. Multiply natin. 101.325 kilonewton per meter squared. Divide by 1.033 kilogram per cm squared. Ito kilogram force to. Kilogram force din yan. Plus VD. 4 times Q na binigay dyan, 0.5 meter cube in every second. Divide by pi. Divide na natin yung 450 ng 1,000. That will become 0.45 meters. Square the value, divide by 2 times 9.81 meter per second squared. Okay. And then, nakasquare rin taas, plus head loss total of 1.5 meters. We can now calculate the value. So, 30 plus 1.5 plus taas, 101.32 and 5 divide by 1.033 divide by, may kulang tayo dito, 9.81 kilonewton per meter cube. Let me check muna yung number 2. Nakalimutan ba ako dyan? Hindi ko naman nakalimutan. Okay? 9.81 plus taas. Huwag mo kalimutan na square na agad siya para hindi ka nalilito. Okay? So, this is 4 times 0.5 divide by pi times 0.45 square natin yung value. 2 times 9.81. The answer will be 42. 42 meters. Very basic. Yeah. So, after the discussion nito, mga 7 problems na to, meron tayong mukbang ng karon tayong mukbang ng pumps, panay pumps naman solve natin. Next meeting yan. So, going back to problem number 4. Yan. Problem number 4. Water from an open reservoir A at 8 meters elevation is drawn. So, ibig sabihin, it is elevated at 8 meters. Is drawn by a motor-driven pump to an open reservoir B at 70 meters elevation. 70 o to 8. Okay? The inside diameter of the suction pipe is suction. So, we are talking about suction. So, suction that is 200 millimeter. And 150 millimeter discharge pipe. Okay. 150 mm. Yung size. Okay. Ng discharge. The suction line has a head loss 3 times. Okay. Head loss of suction is 3 times that of the suction velocity. Is 3 times that of the suction velocity head. Okay? The discharge line has a loss of head 20 times that of the velocity head of the discharge line. Head loss and discharge is 20 times ng velocity head ng discharge. Ayan. The pump center line is at 4 meters. Okay, 4 meters. Okay? Naka-elevate siya. The pump center line is, okay, ito daw yung dinodraw niya dito, 8 meters. Yung pump center line is 4 meters above. Okay? 4 meters. Now, ang hinahanap dyan, for discharge rate of yung Q, 10 liter in every second, find the total head. Ngayon, meron kang dito mapapansin. If dinodraw mo yung water at 8 meters, nandito daw yung reservoir. Ayan. 4 meters ang pump center line from the reservoir. Ibig sabihin, ito accounted for 70 meters from the center line. Okay? 70 meters from the center line. Okay? So, ibig sabihin, from here up to here 70, pero meron kang center line na 4 meters from the pump. Okay, dun maapektuhan yun. Now, yung ZS mo will be equal to, above yan, di ba? So, that is 8 minus 4. Kasi nga, above the reservoir yung pump mo. Yung ZD mo naman dito is 80. 80 ba yan? Nakalagay dyan. 70. 70 minus ulit natin yung 4. Itong nasa baba. Okay? So, yung center line mo is above nung reservoir. Okay? So, let us get yung ating values. Now, hindi natin basta-basta makukuha yun. Hanapin muna natin yung velocity for suction and discharge. So, velocity at suction, that is 4Q over pi d s squared. So, 4, ano yung Q mo dyan? Discharge is 1.5, 10 liter per second. 10 liter per second. Adi, gawin natin siyang cubic meter per second. So, you have 1,000 liter in every 1 cubic meter. So, that is 0.01. Tama ba? Mabawasan ng isa eh. 0.01 cubic meter in every second. Right? I-check mo pa yan. Ganito, meron tayong note dito. If no reference line is given, ZD and ZS only. Pero pag may sinabing reference line, below or above ng pump center line mo, i-compensate mo yung magiging total elevation nila. Okay? Dito, meron kang binigay na reference line. Dito, meron kang center line of pump. I-compensate mo parati yun. Okay? Alamin muna natin to. Tama ba yung ginawa ko? So, 10 divided by 1,000. That is 0.01. Correct ako. So, meron tayong 0.01 meter cube in every second. Divide by pi. Okay? Pi tapos ds dyan. Suction, that is 200 mm. Divide mo na ng 1,000. 200 divide by 1,000 meters squared natin. Anong value? Store natin kay A. Tapos yung V, hindi, dapat to B. Pwede na rin. VD equal to 4Q over pi D squared equal to 4 times 0.01 meter cube in every second divide by pi times 150 divide by 1,000 meter tapos square mo. Okay? So, i-store natin yung value niya kay B. Calculate natin. This is 4 times 0.01 divide by pi times 200 divide by 1,000 squared. The value will be stored to letter A. Pagpalagay na lang natin, 4 na decimal units, 3183 meter per second. Okay? Next one. Store natin yung value niya kay A, di ba? Papalitan mo na lang to. 150. VD is 0.5659 meter per second. I-store natin yung value niya kay B. Yan. We can now solve for the total dynamic head. Now, total dynamic head there is equal to ZD minus ZS, okay, plus VD squared minus VS squared over over 2G plus PD minus PS over gamma plus yung head loss natin dito. Head loss na 3 nung HS thrice of the velocity head ng suction plus 20 nung velocity head ng discharge. Okay? Solve natin. So, ZD is, palagay natin, ZD is 70 minus 4. That is 66 minus ZS 8 minus 4, that is 4, plus BD, the letter A, and the letter B to. In-store nating value kay B. Lagay ko, letter B squared minus A squared divided by 2G. Velocity head yan, ha? Plus PD. Yung pressure natin dito, may binigay ba? Walang binigay. So, this is canceled, 0. Plus 3 thrice nung velocity head ng suction. O, ito yun. O, yung suction natin is A squared over 2G plus 20 discharge naman B squared over 2G. We calculate the value. Okay. Nakastore yung mga value niya, di ba? Pwede na natin siyang matapos. So, 66 minus 4. 66 minus 4, that is 62. Plus alpha B. We recall the values of B and A. Minus alpha A squared. Yun yung mga value niya. Ito yan, yung mga value niya nandito. 2 times 9.81 plus 3 alpha A squared divided by 2 times 9.81 plus 20 multiplied to alpha B squared divided by twice ng 9.81. The answer will be, check na natin anong answer dyan. The answer is 62.35. Okay. 62. The answer will be 62.35 meters. Very basic. Okay? How about problem number 4? Konti na lang po. Konti na lang. Matatapos na rin tayo. A pump is to deliver 80 GPM, gallons per minute, of water at 140 degrees Fahrenheit with discharge pressure of 150 PSIG. IG, ibig sabihin, in gauge. Suction pressure, okay, nasa gauge. Indicates 2 inches of mercury vacuum. Okay, ito yung discharge niya, in gauge. Tapos ito yung mercury in vacuum. The diameter of the suction and discharge pipes are 5 inches and 4 inches respectively. Find the total head. Now, hanapin natin yung total head. Total dynamic head. Velocity head plus elevation head plus pressure head plus head loss. May binigay ba diyang head loss? Wala. May binigay ba diyang discharge head? Meron. Makukuha natin to. Elevation, walang binigay. So, meron lang tayong dalawa. Itong velocity and pressure. So, extract natin. Okay, anong gagawin mo dyan? Una, kung gagawin mo dyan, ang gusto ko kasi dyan, hanapin ko muna yung mga velocities. Okay, velocity muna. Velocity at suction, tapos discharge. Suction, velocity. 4Q over pi d squared. Okay. 4 times 80 gallon per minute. Dapat to naka cubic foot per minute. Okay. Gallon per minute. Calculate. So, 1 minute. 1 minute in every second. In every 60 seconds. times 7 point, hindi, baliktad. 1 cubic foot in every 7.481 gallons. Divide by 4Q, okay. Pi D. Ano hindi mo dyan? 5 inch. Dapat to naka-feet times 1 foot in every 12 inches squared. What will be the answer? Store natin tong value nito kay letter A ulit. How about naman yung VD? So, 4 times 80 gallon. Hindi mo nagbabago yan. Times 1 minute in every 60 seconds. Multiplied to 1 foot cube per 7.481 gallon. Divide by pi multiplied to 4. Okay? 4 inch times 1 foot per 12 inch squared. Okay. Store natin yung value nyo kay letter B. Calculate. Okay? Calculate muna natin. So, 4 times 80 divide by 60 times 7.481. Divide by pi. 5 divide by 12 squared. The answer will be 1.3071 feet per second. Okay. Feet per second. Store natin yung value nyo kay A. Yan. Ulitin natin. Huwag na tayo magbago. Isa lang naman baguhin natin dyan. Ito gagawin lang natin 4. Yan. 2.0424 feet per second. Store natin yung value nyo kay B. Okay. Now, recall natin yung mga values. Okay, you are given their discharge pressure. Kailangan maging absolute to. 150 PSIG. Kailangan absolute to. Yung suction is in 2 inches Hg. Ayan, 2 inches Hg. Kailangan alamin natin to. Vacuum to. Ayan. Ano ang paraan para to maging absolute? Just add 14.7. Ito naman, i-convert mo to PSI. How will you convert? So you have, ano yung conversion mo dyan? You have 14.7 PSI. Equal yan sa 29.92 inches Hg. Ayan yung conversion factor niya. Huwag mo kakalimutan. Alamin natin to, yung head ng pressure. Pressure head, PD minus PS. Isa-isa to kasi mahaba. So, PD, ano yung discharge mo? 2 inches vacuum. Hindi. 2 inches. Ayun pala, 150 PSIG. So, PSI, A ba to o PSIG? PSIG. 150 plus 14.7 PSI pound per inch cube. Inch squared. Okay, tapos kailangan to 144 inch squared 1 feet squared. Kailangan maging feet cube yung nasa ilalim. Minus yung naka-vacuum. Minus ulit. Lagay mo dito, naka-vacuum yan 2 inches Hg multiplied to 14.7 PSI Tapos, yung 29.92 inches HG. Kulang pa yan kasi naka-pound per square inch. Okay? Multiply ko ulit ng 144 inch squared per 1 foot squared. Ayan. Divided by, okay, recall. Ito, ano bang value nito? 62.4 pound per feet cube pag water. Ngayon, feet cube, anong lalabas dito? Feet squared, isang feet. Okay, may pound sa taas, pound cancel yung pound, matitira is feet, aakit siya. Okay? So, we calculate the value, PD minus PS. Saan na lang? Okay, isang calculation na lang. 150 plus 14.7, 164.7. Kapag kaya i-mental math na. Times 144 plus 2 times 14.7 times 144 divide by 29.92. Okay. Divided by 62.4. 382.34 feet. Okay, hindi pa tapos yan. Meron ka pang velocity. Okay? So, head total is velocity head plus pressure head. Velocity muna, 2.0424 feet per second, square the value, minus 1.3071 feet per second, square the value, divided by 2 times 32.2 feet per second squared. Minsan, pwede mong gamit 32.174. Okay lang yun. Plus yung value na kuha natin pag pressure head. 382.34 feet. What will be the answer? So, dito tayo. Recall natin si B. Square the value. Minus, recall natin si A. Square the value again. Alpha A. Divide by twice ng 2.32 times 32.2 plus 382.34. The answer is, yun lang nadagdag, 382.37. That is for problem number 5. Last two problems, number 6. Determine the head needed to be covered if the pump has an 8 inches nominal suction size. Okay? Suction. And 6 inches nominal discharge. So, sa suction, that is 8 inch. Sa discharge, that is 6 inch. If it handles 150 GPM of water at the suction line. Ano nga to? Ano ba yung problem na ito? Tignan ko nga yung notes. Ayun. Wala itong 150. Huwag niyong pansinin to. The suction water. Tanggalin itong at. The suction line gauge shows 4-inch vacuum. Okay? 4-inch mercury vacuum. And the discharge gauge shows 26 psi. So, naka-gauge. The discharge gauge is located at 2 feet above. Ay, hindi na pala natin to. Itong pump na ito, hindi na natin siya i-convert ng, hindi na natin siya lalagyan ng 14.7. Okay? Okay. Naalala ko na kung anong ginagawa ko dito. As is lang to, yung 150. Pag naka-gauge, lahat naman yan naka-gauge. Lahat yan naka-gauge. So, 150. Okay? 150. Lahat naman yan, mame-measure mo in gauge inside the piping. So, this is 382. Bale, edit lang natin. Okay? So, 150 times 144 plus 2 times 14.7 times 144 divided by 29.92. Divide by 62.4. 348. Okay? 348 siya. 348.42. Babago lang yung answer dyan. So, nandito pa rin naman, nakarecall yun. Alpha B squared minus alpha A squared, the value, divide by twice times 32.2. Add natin si 348.42. Maikli lang. Maliit lang yung magiging sagot dyan. 348.46. 348.46. Yun ang magiging sagot. Ayun, naalala ko na. Hindi mo kailangan pala siyang i-absolute kasi pag inside the pipe, gauge talaga yan. Okay? Huwag mo na i-absolute yun. Okay na yun. So, going back, yung PS natin dito, suction is 4 inch Hg. Vacuum yan, so negative. In discharge, that is 26 psi. Kunin natin yung head total. The discharge gauge is located 2 feet above the center of the discharge pipeline and the pump inlet and the discharge lines are at the same elevation. So, same elevation, wala mangyayari, wala kang elevation head. Okay, same elevation eh. Okay? Same elevation. Ano lang ang meron ka dyan? Yung pump and then the velocity head. So, velocity head plus elevation head plus pressure head plus head loss. Binigay sa'yo same elevation eh, ano? Same elevation. Ibig sabihin, wala ka nito. Tapos wala kang head losses. Ito lang dalawa meron ka. So, HV equal to HV equal to 4Q over pi DD squared. Squared natin to. Total ko na. Head total ko na. Head total na yan. Diretsong calculation. Head total. Minus suction 4Q over pi ds squared. Yan. Squared natin. Divide by 2G plus yung PD minus ES divide by gamma. Hanapin natin si Q. Q is equal to 150 GPM. Dapat to naka-feet per second. Cubic foot per second. Okay? 150 gallon per minute. So, multiply mo ng 1 minute every 60 seconds. Multiplied to 1 feet cube divide by 7.481 gallon. ilan? So, 150 divided by 60 times 7.481. The answer is 0.3342. So, 0.3342 cubic foot in every second. Pasok natin yung value niya dito sa calculation. Dire-diretso na. So, head total is equal to 4 times 0.3342. Natin lagay unit, okay? Yan, divide by pi times dd. Naka ano yan? 6 inch. Divide mo na ng 12 para maging feet. 6 divide by 12 feet squared. Tapos naka-square din yung labas. Minus 4 times 0.3342 divide by pi over 6 ba talaga yun? Discharge 6. Suction is 8. Tama. 8 divide by 12 inch squared. Hindi, feet na yan eh. Squared. Tapos square mo uli yung value. Divide by 2 times 32.2 feet per second squared to Lalabas dito feet. Plus PD. Yung discharge mo. 26 PSI. Ay pound per inch squared. Multiply mo kagad ng 144 inch squared. Divide by 1 feet squared. Yung vacuum, negative. Diba? Negative yan. Minus, minus. O di plus na. Inches HG. 4 inches HG. Multiplied to PSI, 14.7 pound per inch squared. Divide by 29.92 inches HG. Makakancel yung unit na yan. Kulang ka pa ng conversion factor. Pag may nakita kang pound per inch squared, i-multiply mo na kagad ng 144 inch squared over 12. Dito, 12 tuloy. 1 foot squared. Divided by 62.4 pound per feet cube. Ang lalabas dyan, feet lang. Dire-diretsong solving. Okay? Unahin natin to. Dire-diretso na tayo. Okay. 4. Taas muna. Okay. Square mo. Minus. Square. Ayan na. Ayan. Ayan. Square na, di ba? So, 4 times 0.3342 for 1. Okay? Divide by pi times 6 over 12.5 squared. Square na. Ano yun? 4 times 33342 divide by pi multiplied to 8 divided by 12. I think that is 0.75. Hindi ako nagkakamali. Squared kasi 3/4 yan. Kung simplify mo. Tanggalin mo yung 4. 3/4. Hindi. Ilan yung 4 dyan? 2. 2/3 pala. 2/3. Sorry naman. So that is 0.67 kung di ako nagkakamali. So this is 8 over 12 and 2/3 nga. 2 over 3. Square natin yung value. Tapos naka-square, okay? Divide by 2 times 32.2. Okay. Store natin yung value na kay letter A plus okay. So, ayan. Taas muna. Okay. 26 times 144 plus 4 times 144 times 14.7 divided by 29.92. Divide by 62.4. Add the value nung letter A. Ilang feet yan ang lalabas? 64.56. Yan. 64.56 feet. May kulang pa ba tayo? Okay. Wala na ata. Okay na yan. May nilagay ba dyan? 2 feet above the pump center, the discharge pipe and the pipe inlet are at the same elevation. The discharge gauge is 2 feet above the center of the discharge pipeline. So, plus 2 pa pala to. Plus 2. Okay? Plus 2. Equal to 66.56 feet. Yan. Hindi ko nasamahan ng 2. Plus 2. Ayan. Okay? So, last problem. A vacuum pump is used to drain the flooded mine shaft of 20 degrees Celsius water. The pump pressure of water at this temperature is at 2.34 kPa. The pump is incapable of lifting water higher than 10.16 meters. What is the atmospheric pressure? Okay, going back to Bernoulli. So, meron kang P1 over, yan, para makuha natin yung head. Energy in, di ba? Energy in equal to E out. Plus V1 squared over 2G plus Z1. Wala ka namang head losses. Okay? Suction. Tapos P2, okay? Plus V2 squared over 2G plus ZD o Z2 plus head loss discharge. Wala ka dyan mga head losses. 0. Wala ka naman binigay na sizes tsaka flow. 0 rin to. 0 rin to. May binigay kang elevation dyan. Sa suction, wala. Sa discharge, meron. Ang hinahanap mo dyan is atmospheric pressure yung pinagmulan niya sa P1. Meron kang binigay na P2. Pump pressure of water, 2.34 kPa. So, reform the equation. So, P1 over gamma equal to P2 gamma plus Z2. Nahanap mo si P1. O, di P1 will be equal to gamma multiplied to P2 gamma plus Z2. Okay. So, you have gamma. Ano ba ang gamma ng water? 9.81. So, let us go with the calculation nito. So, yung gamma is 9.81. 81 kilonewton per cubic meter. And then, meron kang P2. Yung P2 mo is binigay dyan. Anong binigay sa P2 mo? 2.34. 2.34 kilonewton per meter squared. kPa yan eh. Divide by 9.81 kilonewton per meter cube plus Z2. Yung Z2 mo is, ibinigay dyan, your pump cannot lift more than that. So, that is 10.16 meters. Sinabi niya, cannot lift, ayan o. Cannot lift water higher than 10.16. Ibig sabihin niya yung hangganan niya. So, dito, pag minultiply ko ito, ang lalabas, dapat dito, 2.34 kilonewton, cancel ito, 2.34 kilonewton per meter squared plus 10.16 meter multiplied to 9.81 kilonewton per meter cube. Cancel mo lang isang meter dito tsaka isang meter dito. So, the answer will be 2.34 plus 10.16 times 9.81. The answer will be how many? 102.01 kPa. Yan yung pressure niya at the suction. Okay? So, I think that will suffice for Bernoulli principle. Okay? Next meeting, you'll have pumps.